The amounts of nicotine in a certain brand of cigarette are normally distributed with a mean of 8.7 milligrams and a standard deviation of 1.6 milligrams. The company that produces these cigarettes claims that it now reduced the amount of nicotine. The supporting evidence consists of a sample of 31 cigarettes with a mean nicotine amount of 8.211 milligrams. Assuming that the given mean and standard deviation have not changed, find the probability of randomly selecting 31 cigarettes with a mean of 8.211 milligrams or less. So we're looking for a probability. We're looking for a probability that a sample has a mean of 8.211 milligrams or less. So at no point were we told that the distribution no. We were told that the amounts of nicotine were normally distributed. We didn't actually have to be told that because we have a sample that is greater than 30, and the central limit theorem would have guaranteed that the sampling distribution would have been normally distributed anyway. Either way, we are working with a normally distributed set of data where the mean is 8.7. They're back in the problem. Standard deviation of this population is 1.6. But since we have a sample of 31 cigarettes, we are going to take that and divide by the square root of 31. So we're not looking at the distribution of the population, we're looking at the sampling distribution now. And the sampling distribution has that reduced standard deviation. So the mean is still located right in the center of the distribution. And what I'm looking for is the probability that the mean is 8.211 milligrams or less. So that is somewhere down to the left. And we want that or less, so I'm shading to the left. So to find the area under a normal distributions curve, I use the normal CDF function, which takes 4 inputs. The first 2 inputs are the lower bound and the upper bound of the shaded region. So I need to go from negative infinity, which I'm going to use negative e to the 99th, so that's just negative 1 times 10 to the 99th power, so something small, and 8.211, which is the upper bound of the shaded region. The mean is 8.7, and the standard deviation is 1.6 over the square root of 31. Now, to put that in the calculator to get this probability, second in distribution, which is on the vars key, come down to normal CDF, and I have negative e, so second and comma gives me that e, so 99, so that's negative infinity, 8.211, 8.7, and finally 1.6 divided by, make sure you don't forget the division, the square root, so second and square gives you square root 31. Press enter and you get 0.0444. So that is the probability, which is not a very large probability, but one thing I want to mention real quick is some of you may have seen a menu show up as you did that process. And that's okay, it just means you have one of the later model calculators. And so all this is doing is helping you remember the order of the inputs, and it's actually a little bit easier to type those in because you don't have to worry about the values scrolling off the side of the screen. But everything works the same, you just put the values in line by line. When you get to this last one, it is perfectly okay to just put 1.6 divided by square root of 31. The calculator will know exactly what you mean there and handle it accordingly. Okay, now the next part of this question says, based on the result above, is it valid to claim that the amount of nicotine is lower? So the probability that we find 31 cigarettes that have this amount of nicotine or less is really small. So if we did find this, then something is happening that probably shouldn't happen because it has such a low probability. So the question says, is it valid to claim that the amount of nicotine is lower? I would say yes. So it's a valid claim, and the reason being, the probability of this data is unlikely to have occurred by chance alone. Because the probability is so small, it's probably not happened just because of random chance. So it's probably happened because the nicotine actually is lower in these.